Okay, hi again, everyone. Welcome back to our statistics class notes. We are in Chapter 5, Section 5.2, in the middle of page 64, and we're talking about computing probabilities with the general probability rule, and understanding and or as well. Okay, so here we have what's called a contingency table. So this is a contingency table, which is just a two-way table, which summarizes results from a fictitious survey that asked about political party affiliation and who they supported in the 2016 presidential election. So there was two questions summarized here. All right, so people were asked, did you support Clinton, Trump, or someone else? So they had to pick one of those three. And then they were also asked, are you a Democrat, a Republican, or something else? And they asked one of those. So for example, these 209 people answered that they supported Trump and they were Democrats. Okay, the total, when you add across, so these are all the people that supported Clinton. There were 930 out of the 2,802 people that were asked this survey. Trump, 1,045 out of the 2,802, and other 827 out of the 2,802. Similarly, if you go down a column, 821 out of the 2,802 said they were Democrat, etc. So we're going to complete this and use 3 decimals as we can. So what is the probability of randomly selecting a person who is a Democrat? So let's call that, let's say D is Democrat. So what's the probability of getting a Democrat if I randomly select one of these 2,802 people? So there were Democrats, or this column. So all the people that answered Democrats were 821. So there was 821 out of 2,802, which comes out to be 0.293. Or if I want to change that to a percentage, it's 29.3%. What's the probability of randomly selecting a Trump voter? Okay, and a Trump voter, these are all the people that supported Trump. If you go across this row, so there were 1,045 people out of my 2,802 that supported Trump. So that's 1,045 out of 2,802. So that's 0.373 or 37.3%. What is the probability that a person is a Democrat and a Clinton voter? So we got Democrats in this column, we got Clinton in this row. So where they intersect, that's a person who voted for Clinton and was a Democrat. So 502 out of my 2,802 people. So 502 out of the 2,802 people that were surveyed were Clinton and Democrats. So that's 0.179 or 17.9%. What's the probability that a person is either a Democrat or a Republican? So we want to include all the Democrats or Republicans or both. Remember, or means or both. Now, there's no way to be both. Other does not mean both. It means it's something else, independent or something like that. So Democrats or Republicans were 821 out of the 2,802, and Republicans were 1,160 out of the 2,802. So you add those together, you get 1,981 out of the 2,802, or 0.707, or 70.7%. Now, what's the probability that a person is either a Republican or a Trump voter? So we want Republicans or Trumps or both. Okay? So Republican or Trump. So all the Republican voters were this one, 1,160 out of the 2,802. So if you count all those up, 1,160 out of 2,802. Now all the Trumps were this row, so that would be 1,045 out of 2,802. So that's my first two numbers here. But notice, by counting this row and this column, I've counted where they intersect twice, right? I've counted this 524 twice, and I should only count it once. So I got to subtract that out one time. So minus 524 out of 2802. So in total, that's 1681 out of 2802, which is 0.600 or 60%. Now I have some notes on the side here, but that needs to come from my next definition. So events in which there are no common outcomes are called mutually exclusive. So notice in parts A through D, there were no common outcomes. Even when I had an or here or an and, there were no common outcomes. Okay, so the thing is, those are all mutually exclusive, no common outcomes. The problem here in part E is that I had a common outcome, right? Republican or Trump. So Trump Republican. This common outcome is the Republican and Trump, right? This 524. So that is not mutually exclusive. So what I have to do when I'm doing an OR rule, if I want to come up with a probability rule for OR, I'm going to add the probability for A, like I did here, add the probability for B. So in this case, that was Republican Trump. So A is R, B is T for Trump. But then I had to subtract out where they intersected, the and part, where this Republican and Trump, because I counted it twice by counting it in these first two probabilities. So I got to subtract it out. Now, if it's mutually exclusive, like events A through D, and I have an and, like I did, then the probability of A or B didn't have a, well, see, I had an A or B in this one, part D, which is mutually exclusive. There is no intersection of Democrat and Republican, so I don't have to subtract anything out of there. So a mutually exclusive event, the probability of A or B is just the probability of A plus the probability of B. But if A and B have something in common, I have to subtract out the probability of A and B.